Okay girls, hi again. Now I'm just going to continue on through the handout that I've given you. So I'm looking at question 19 on that sheet. I've just started to draw the diagram. So it says there are two uniform rods, RP and RQ. R, P and Q. They are rigidly jointed at R. They're of equal length and they each have a mass of m kilos. PO, this position O, PO, OQ and OR are all 0.2 meters. And it says, give a reason why the centre of gravity of the two rods lies on the line OR. Okay, so normally in the law of the lever we'll say, if you find the moments about the anti-clockwise moments and the clockwise moments, and if they're equal, then that will tell you that that's where the line of the centre of gravity is, or the position of the centre of gravity is. So that's what we're going to do. We're going to do that. We're going to use the sum of the moments to find the position of the centre of gravity. Right, so first of all, we know they're equal rods. We know they have a mass of m. So that means that's a weight force and that's a weight force. So I'm going to call that mg, mg. I know the distance from here to here is 0.2, and from there to there is 0.2, and I also know that the distance from there to there is 0.2. Okay, so let's have a look at the forces. We're going to use the law of moments, so let's look at the forces, the positions of the centre of gravity for each rod, the moments about the x-axis, and the moments about the y-axis. So continue what we were doing earlier in the sheet. So the force, if I call this rod A and that rod B, the force for A is m times g, and for B is also m times g. Now look at the position of the centre of, we'll say the position of the centre of gravity for A. So that's the position where its mass acts. If I was to consider RO to be the y-axis, and this PQ is along the x-axis, then this position here, look where it's acting. Where is this A acting? What's its distance from there? So from here to here, that's the distance. And from there to there, of course, that would be the distance. So the position of where it's acting. So for this one here, and this will be the same, B rod will be the same. The position from there to there, of course, will be acts halfway along. So therefore, it's going to be at position 0.1. Right then, so my mg, let's take the A. The A rod, what's the position of its centre of gravity? Well, it's to the negative side of the x-axis, so it's minus 0.1, and of course it's 0.1 up. And for the B rod, where does this centre of gravity act? It acts out 0.1 on the positive side of the x-axis, and again 0.1 up, because these are all 0.2 distances, those first. That's going to be halfway along, the centre of gravity acts halfway along the rod, so halfway up. Right, the moments about the x-axis would be mg times 0.1, and for this one it would be mg times 0.1. The moments about the y-axis, for this one it's going to be minus mg by 0.1. I'm multiplying it by the x-coordinate, and again this one will be positive mg by 0.1. Okay, now then I can just use my law. I have to find the resultants. So this is going to become, when I add them, 2mg. I don't know where the centre of gravity is. I'll call that xy. This will become, when I add those, 0.2 mg. And when I add these, I'm just going to get 0. So when I use the law of moments, which is the sum of the moments equals the moment of the sum, equals the moment of the sum, about the x-axis, what's it going to be? So my x-axis moments are 0.2 mg. The moment of the sum about the x-axis is 2 mg by y, which means that y is equal to 0.1. the moments about the y-axis, I'll do the same here now, will become 0, the sum of the moments is 0, equals the moment of the sum. The sum is 2 mg, and about the y-axis, of course, that's x. So x is 0. So my centre of gravity is at the position 0, 0.1, which of course makes sense. Centre of gravity of that system here will be 0 along the x-axis and 0.1 up the y-axis. So the centre of gravity, therefore, lies on RO. So this centre of gravity is on the line RO, here, RO. Okay. Now the second part of the question says, find the distance of the centre of gravity of the two rods from O. Well, if this is the position of the centre of gravity, what is the distance of the centre of gravity of the two rods from O? So here's O, what's the distance? Here's the centre of gravity. What's that distance from O? How far up the y-axis, in other words, which is 0.1 metres. So 0.1 metres from O. And that's that fella. So that's the first part of that question. Now let's have a look at the second part. And this was an old exam question, that's why I'm putting it in here. Now it says the diagram, I'll just sketch the diagram. We have the two rods again that we've just spoken about, and then we've got two discs, and we have this kind of idea. So it says we've got this advertising sign for an optician's. This is RP, RQ. This line is AB. It says they're rigidly joined at P and Q to these two discs. So these rods rigidly joined to the discs. AB is a horizontal line which passes through the centre of the discs and through PQ. And the distance from R to AB is 0.2. So this distance here again is the same as in the previous question. So from R to 0 was 0.2. So this is the same. You've got to find the distance of the centre of gravity now of this sign from the line AB. So find the position of the centre of gravity of the sign. Right, so we're going to use the law of moments again. So we're going to set up my table. I'm going to use force, the positions of the centre of gravity of each part. I'm going to get the moments about the x-axis, and I'm going to get the moments about the y-axis. Okay, I'm going to label each part here. So I've got rod A again and rod B. I've got disc C and disc D. So A, B, C, D. And it tells me each of these discs has a mass of m kilos. So I've got all of them kind of marking the masses or the forces for each one of them. So this is mg, this is mg, so is that, and so is that. mg, 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 mg. So mass by acceleration due to gravity. Right, so the forces for A, or the force for A is its weight, which is the same for the four parts of the structure. Right, the positions. The centre of gravity of A, we already know where that is because we found that in the first part, remember? It's minus 0.1.1. So this one's minus 0.1.1. The centre of gravity for B, again, we already know 0.1.1. 0.1, 0.1. The centre of gravity for C. So how far, we'll say, where exactly is it? If this is the x-axis and this is the y-axis, where is that position there from O? So this position, if that's going to be the origin, we'll say this is my y-axis, that's my x-axis, so that's the position O, the origin. Where is this from O? So we can see it's 0, this bit here, the radius, remember, each disc has a radius of 0.2. So this is 0.2 from there to there. And this is 0.2 also, which means that that distance is minus 0.4 from the origin. And 0 because it's not up the y-axis, it's on the x-axis. D's centre of gravity, here it is, it's over there. Again, this is 0.2 from O to Q, and this is also 0.2 from Q to the centre. So that is going to be 0.40. So finding those distances is where your work is. Right, moments about the x-axis. We're going to multiply 0.1 by mg, and we just get 0.1 mg. We're going to do the same for b, 0.1 mg. These two fellows will just become 0 when I multiply mg by 0. Moments about the y-axis will be minus 0.1 mg, because I'm multiplying it by its x-coordinate. This one will become 0.1 mg. This one will become minus 0.4 mg, and this one will become 0.4 mg. So stop the video, see where we got those distances from, make sure you understand that. Now I'm going to put it into the law of moments, so I'm going to find the resultant. The resultant is 4 mg. The position of the central gravity, I don't know where it is, I'm not looking for that. I'm going to add the moments about the x-axis, that gives me 0.2 mg. I'm going to add the moments about the y-axis, and that will just become 0. And then I'm going to use the law of moments, which says the sum of the moments equals the moment of the sum. So about the x-axis, I'll do the x-axis first. So this is going to become 0.2 mg is my sum of the moments about the x-axis equals 4 mg times y. The mg's will cancel, and that will go in 0.2 over 4, which is 0.05. Then I'll do the y-axis moments. So the sum of the y-axis is 0 equals the moment of the sum about the y-axis, which is 4 mg times x, which of course means x is 0. So my centre of gravity is 0.05. And the question says, find the distance of the centre of gravity from the line AB. So here's my line AB, that dotted line there. The position of the centre of gravity, well, the centre of gravity is at 0.05. So 0.05 will be up there, somewhere around there. So what's the distance of that position from that line AB? So it's going to be this bit here, 0.05 metres, which of course is 5 centimetres. So it's 5 centimetres from the line. So have a look at that a couple of times, girls, make sure you understand it.